Are you wondering why I have this red light on my face? Well, the answer is simple. I built a robot that shines a laser in your eye. First of all, I want to point out that I am aware Michael Reeves has already made this project. That's one of the reasons why I made mine in the first place. But there are two problems with this robot. The first one is that it's very big. It takes the space of a pizza box. It also uses a lot of power. It needs 3 power adapters to run it, whereas mine only uses the power from the Arduino. I actually don't know if that's what you should do. I don't know if it withdraws too much power from the board. It worked so far, so I'm probably not going to use it after this video. Also, his one detects faces, not eyes. So it doesn't really accurately blind you. It kind of blinds you when it meets your eyes, but it kind of like tracks your face and shines the laser at your face, hoping it will blind you. It does have longer range though, because if I back up more than I should for mine, it won't detect my eyes anymore and it will stop working, but at least mine is more accurate. As you can see, I made the robot out of a webcam, an Arduino, a breadboard, 2 servos, a laser diode, and also a peanut butter jar filled with rocks for stability. And I know what you're thinking, holy shit George, that looks like a very solid project. I bet that if you get in contact with the British Army, they are willing to buy it off you. And I know that's true, but I don't support the war, so I wouldn't think of selling it. For the facial recognition part of the project, I used EMGUCV, which is a wrapper allowing you to use OpenCV for the .NET languages. Firstly, I started off programming in Python using OpenCV because I thought, you know, since OpenCV was designed for Python, it would be better to use it in that language. But then I found out that using serial communication in Python is a real pain in the ass. So I stopped using Python and switched to C#, because I know that Michael has a video about making a laser turret, meaning that he has a tutorial on how to use serial communication in C#. So that was my first resource, and then my second resource was some random Indian guy with a tutorial on how to use facial recognition in C#. Now, using Michael's tutorial and also the other guy's tutorial, which both I'm going to link in the description, I had my work cut out for me pretty much, but there were still some problems that I had to solve. The first problem I had was detecting an eye. Now, that one is pretty simple because all you have to do is just copy what you did for the face, but replacing the heart cascade with the right eye, which is a dedicated cascade that helps you detect bright eyes. It's kind of straightforward, to be honest. The second problem I had was the coordinates of the box that is drawn around your eye when it's been detected. So for the program to detect stuff like faces, eyes, or even hands, it needs to analyze the frames in grayscale, which is handled by this line of code.
Don't worry, I don't know what those variables do either.
After the ROI has been detected, the program takes the image of that, holds it into memory along with the coordinates of the upper left corner, because it will be using that information later on to draw the little box that you see around when you see the webcam video feed. So the way the program draws the box is to determine the point in the upper left corner and also the point in the bottom right corner, and determine a diagonal and then build a rectangle around it. And the way it determines the bottom right corner is with this formula here. So from that formula you can determine the point that the laser is supposed to hit, because you know it's going to be midway in the image, so it's going to fall, you know, more or less on the pupil. So yeah, hence the accuracy. And the way you determine that point is this, which is, you know, it's kind of simple, like it's just halfway from that diagonal I was talking about earlier. It's all simple now, but it kind of took me a day to figure out. So when I found out how to call the coordinates from the box, I was done, right? Wrong. You see, you can't really use the coordinates as they are because, you know, servos don't rotate to 640 degrees, unfortunately. But even if you were to use the formula that Michael has provided in his tutorial, which is very useful for the mouse bit, not so useful for the face bit, you would still get maximum rotation when you go to one side or the other in the camera frame, even though you don't go that far as the entire rotation of the servo. So my mission was to find the angle of the camera lens and try to map that to the servo somehow. And that's what I did. So first of all, I found out that a Logitech C920 has a 78 or 79, I'm not sure, degree diagonal angle, which meant I still had to do some digging to find the horizontal and the vertical angle of the camera. And I did, using this chart right here. It doesn't really give me 79 or 78 on the chart, but I used 80. It's close enough. I don't think the point wherever many degrees of error is going to count that much. The most I'm going to do with this is just make myself wear glasses, because thankfully my eyes are fine. Well, were fine before starting to make this project. I was going to finish working on this robot much sooner, but you know, I didn't identify the problem, mainly because I was kind of very high on dopamine, because I actually had something that worked, even though my servos would spin too much and they would overshoot by a shit ton. So yeah, and with these values I was able to determine the minimum and the maximum that the servo should rotate to. And I have made this formula here, which I know looks very complicated, but it's not. So for the minimum is 90 minus angle divided by 2, and for the maximum is 90 plus angle divided by 2. And angle can be replaced by the angle for the horizontal axis and also the vertical. So yeah. So after finding the minimum and the maximum values for the X and Y servos, I headed to the Arduino IDE and I mapped the minimum and the maximum values to the incoming values from the C# program, and those values are the ones I was talking about, the coordinates in pixels, not in, you know, in servo angle. And then I let the Arduino do the actual maps on how much it's supposed to rotate depending on how I'm moving in front of the camera. And I don't know, if I was to code it in the C# program, maybe it would have run a little bit faster. It works well now, so who knows, maybe I'll try to change it someday. And that's kind of it about this project. What can I say? I enjoyed making it very much. I'm sure I learned a lot. I learned how to use facial detection technologies, and also I got to use a little bit of maths, because outside of school I didn't get any benefits from actually learning it. So yeah, if you enjoyed this video, you can click the thumbs up button. It will help me a lot, not only with motivation but with the YouTube algorithm. Also click subscribe if you want to see future builds, and I'll see you next time. Bye.